Understanding the latencies of the queries in your database is really important for having a good grasp just generally on the health of your database and how it's performing and how that impacts application behavior. So let's talk a little bit about query latency, specifically numbers like p50, p95, and p99. So let's say that we have a database, and this is a really simple, short, small, compact list of queries. But let's pretend that this was some kind of full list of all of the queries running on our database. What you would probably hope if you have a database that is well designed is, even if there's a lot of traffic on it, even if you have an app with tens of thousands or hundreds of thousands of users and making lots of queries, you'd hope that most queries execute really quickly. A great example would be something like select star from user where ID equals 5. This is what we'd call a point select query, where I'm selecting a single row from the database and assuming that table, even if it's very large, if it's well indexed by ID in this case, I would hope that that would only take a millisecond or 2 milliseconds, or maybe if there's some network issues, right, and some added latency there, maybe a couple of milliseconds, but it should go very fast. For your typical OLTP use case, we would hope that most queries fall into this category, right? Most queries are ones that will execute in maybe 5 or 10 milliseconds or less, that are only either returning one row, point select, or maybe returning a small set of rows, 5, 10, 20 rows. And they could be doing some work, right? They could be doing some aggregating or some summing, but not too large. If we have queries that are taking a very long time and scanning hundreds of thousands of rows and doing big complicated math on them, we would typically call that an OLAP query, because it's more analytical. So anyway, we go through our database, right? And then here's another query where it's doing a point select. That one takes 3 milliseconds. But then every once in a while, we might have certain queries that just require more complexity, right? Maybe in our app, we allow the user to do, like in this case, we're selecting an address and an ID from some location table. We're doing a query that's looking for nearby addresses. So it could be a little more complicated. We might have to scan a whole subset of the table and then do some computations to figure out which locations are closer to the search term, and then aggregate those and then return the top 20 results to the user. So maybe that takes 50 milliseconds, or maybe that takes 100 milliseconds just because it's more complicated. But we'd hope most are short, and every once in a while we have some maybe medium length or even longer queries as things are executing, right? And so the interesting thing is, if you have a busy database and a popular application, you're gonna not just have like 3 different types of queries, you're gonna have hundreds of different types of queries, or even thousands of different types of queries. So it's hard as one person to just look at a list of 1,000 different queries that have executed in the past second or minute and get a good sense by just looking at that. What's the performance of my database? What's the health of it? How are things doing? Are things too slow? Are things running well? So this is where there's a couple of numbers that, numbers that every database engineer, or really just engineer period, because pretty much every engineer at some point has to interact with the database, should know. So what we're going to start with, and they're all related, they're all similar, but is this idea of p50. And basically this means your average query latency. So p50 means you take all of the queries over the course of some range of time. It's always bounded by time. So let's say over the past hour, then what's essentially like the median query execution time. So if we have an OLTP workload, we would hope that p50 is very low. It's something around a millisecond, 2 milliseconds, 3 milliseconds, maybe 5. But we wouldn't want this to really be any more than that, because if we have a database where thousands, millions of queries are executing, even just adding 1 or 2 milliseconds to your p50 means that that is 1 or 2 milliseconds times thousands or hundreds of thousands or millions of queries, which adds up to a lot of overhead, right? So we want to have most of our queries running very quickly. So we'll say like a good-ish number for this is something like 1 to 5 milliseconds. So we've got that, but then we don't want to just look at essentially what our average query execution time is, because just because the average or median is good, we could have a bunch of really slow queries that are past the median. So the numbers that are commonly looked at, and it all depends on kind of what you want to measure, but p90, right? This is essentially like make 100% of your queries, you pick the 90th percentile one, what's the execution time of that? p95 is commonly looked at as sort of an intermediate one, p99. So with p99, what you're saying is, let's take our top slowest 1% of queries, essentially what's the fastest executing query in that top 1%. But again, if you're operating a really high scale database, even that is actually going to kind of hide the performance of a lot of things. So a lot of times people even want to look at the p99.9 and maybe even the max query execution time, right? So p90, you might say, really, we wouldn't want this too much slower. We might still want this to be somewhere around 5 milliseconds. Maybe once we get to p95, this starts to be more like 10 milliseconds. p99, again, some slower queries might be okay. Just depends on your app. So maybe you do have some that are taking 50 milliseconds. And maybe at your really, really slowest, you do have some that are taking 80 or 100 milliseconds. But you would want those to be few and far between, because if all of a sudden those queries spike and a lot more start executing, now that's going to really severely hurt everything else that's happening in your database. Because 80 times 1,000 queries is a lot worse than 80 times 2 milliseconds. A typical OLTP workload might look something like this, right? So vertically here, this is how long they're taking, right? It's kind of a log-ish sort of scale, right? Make this like 100. So it's not linear scale, right? So we have very fast queries down here and slowly get slower. And then this is of all of the queries over my 1 hour or 24 hour or whatever window, kind of where they fall in terms of those percentiles we were talking about. So a good sort of typical OLTP workload might look something like this, right? Like most of our queries, are going like pretty fast. They're all kind of like 5 milliseconds and under. And then right towards the end, we often have a handful of just slow queries that we kind of can't do without, right? So those sort of go up and to the right over here. And this is why if all you were looking at as an engineer, if you were just looking at, p50 right here, you're essentially looking at what this value is, which looks good. Oh, an average of like 4 milliseconds per query, that's great. And even if you were just looking at your p90, that's this point right here, it's like, okay, that's still only like 4 milliseconds, 5 milliseconds, that's pretty good. But then if you then jump up and look at your p99, which is probably like this line right here at the very end, now all of a sudden that's 80 milliseconds. And you're like, oh, I actually do have some slow queries running at that very, very high end. It's a very small percentage of them, but I might need to be careful about those. Because even though that doesn't look that bad here, you might all of a sudden add a new feature to your app that takes that query that was only executing 10 times per minute, and now it's executing 1,000 times per minute, because all of a sudden people are using this new feature and executing a certain query path more often. And then that suddenly bumps your line to start looking more like this, right? Like one addition of a new feature, if you're not careful with indexing and making sure the queries run well beforehand, can all of a sudden take your database from looking like that to looking like this, right? Where you have a lot more slower queries happening in terms of the percentage of all queries. And this is the kind of thing that if you didn't plan for it in ahead, if you didn't write the right indexes, could just take down your database. It could crash it, right? If you didn't upsize or plan accordingly for this. Database engineers, and really just as engineers in general, and this actually doesn't just apply to databases, this also can just apply to like load times for your application. Maybe you're a front-end app engineer or back-end app engineer, but load time has a significant impact on the customer satisfaction and even how much money you're going to make. I think there was a study done by Amazon a while back, and I don't remember the precise numbers, but it was something like every additional 100 milliseconds of load time, like decreased someone's likelihood to buy a product or decreased profits by 1% or something, which might sound small, but if you can take your web page load time from taking a full second to load to taking 200 milliseconds to load, that can potentially have a positive impact on sales, because people are more, they're enjoying your product more, they're enjoying your app more, and then they're more likely to buy the thing because they're having a good experience with it. So this keeping track of p50, p99, p99.9 is important to think about, really, whether you're doing databases or app development, because we want to keep our users happy, and performance generally makes people happier than slow, sluggish applications.